Hello everyone, I'm Bernard Xiong, the founder of ArtistRide. It's my pleasure to meet you here and have this opportunity to introduce the latest updates on ArtistRide in the field of high-end processors, the ArtistRide Smart, a microkernel operating system. ArtistRide Smart, from a big picture perspective, is derived from ArtistRide real-time operating system. It inherits the harder real-time features of ArtistRide and contains the traditional IPC facilities such as semaphore, mutex, mailbox, message-queue, and PEPL. Moreover, it also supports SMP multi-core and fully takes the advantage of the multi-core features on ArtSmart, as well as 32-bit or 54-bit single-core or multi-core. ArtistRide Smart is also a microkernel-like operating system, as it separates the running space into kernel space and user space. To give you an idea here, like the Arm Cortex-A, its kernel runs on EL1, but the application runs on EL0. The kernel has the basic functions, so they can also be loaded and executed according to the actual demands to achieve a faster startup. As some system services run on user space because they are isolated from each other, so the security is greatly improved. On user space, we set up a compatible POSIX environment using muscle libc so that many Unix open source software can be easily ported to ArtistRide Smart. Because we are talking about ArtistRide Smart delivered from ArtistRide open source real-time operating system, let's have a quick review to ArtistRide operating system. ArtistRide was born in 2006 as an open source real-time operating system, and I'm honored to be the creator to launch the first kernel version for this project. ArtistRide has an preemptive multitasking schedule, synchronization, and communication facilities such as semaphore, mutex, mailbox, and the message queue. As it has always wanted to be an open operating system, we are following the POSIX standard and compatible with PLC 15.1, including file system, TCP IP stack with BSD socket interface, which use a socket abstraction layer and LWIP protocol stack, and it also fully supports C++11. And you can find a wide range of software packages on the ArtistRide platform that covers IoT, industry control, system tools, AI, etc. The hardware layer, ArtistRide supports all mainstream CPU architectures, such as Arm, from Cortex-M, R to Cortex-A, RISC-V, x86, etc. And the 15.4-bit and symmetric multi-core processor supported on ArtistRide 3 years ago. Happy to share that so far, more than 1 billion devices are running ArtistRide, and we have received up to 2,000 GitHub stars. The easiest way to think about it, the kernel of ArtistRide Smart is equal to a classic ArtistRide plus the LWP component. It's first based on the ArtistRide real-time operating system with a consistent code branch and reviews a lot of ArtistRide code. The difference is this kernel runs on the virtual address. Thus, on kernel space, if you want to access the peripherals you should try with a virtual address. The LWP, its full name is Lightweight Process, is implemented as a component on RTOS. The LWP refers to process management, virtual management, MMU, etc. The IPC helps with communication between process and process, and process and kernels. It's composited with channel and shared memory, and the process group for TTY and the PTY session. Here, I'd like to highlight the features of RTOS Smart. It's positioned as a small, faster, and safer microkernel-like operating system. The little kernel only contains some basic operating system facilities, like multitasking, scheduling, thread and process management, multitask synchronization and communication, physical and virtual memory and address management, etc. The kernel size is less than 500 kilobytes. Therefore, the RTOS Smart system can boot fast because its system services or application can be loaded into the memory according to actual demands. The fast boot is less than 500 milliseconds. As we mentioned before, the system services is running on user space, so their address space are isolated from each other. Even if one program crashed, it won't affect other services or the system as a whole. The system also has a unified services management program for monitoring and managing other system services. This is the architecture of RTOS Smart. Simply put, there are three layers lookup from the bottom to top: hardware layer, kernel space, and the user space layer. At the kernel level, in addition to traditional basic RTOS facilities, RTOS Smart include process management, address space management, EF loaders, and a new inter-process communication channel and shared memory. Of course, RTOS Smart also shares the interface level of a traditional RTOS, like SA, the socket abstraction layer, DFS, the virtual file system. The footprint of kernel is as small as 500 kilobytes. Some traditional system services are put into the user space, such as the file system, FATFS implementation, user space network protocol stack, LWIP, TCP/IP stack, etc. They all can be run on user space. That being the case, when the user application uses these services, it will trap into the kernel through system calls, and then a step in the kernel can make an IPC messaging and then transfer to the user space service process. Besides, in the user space, we also prepare an RTOS traditional API layer so that the RTOS application can also be used to develop programs on the user space. For that reason, we are able to expand the packaging ecosystem of RTOS to RTOS Smart. Security is realized on RTOS Smart. RTOS Smart separates the overall system into kernel space and the user space. It's say a 32-bit Cortex-A7. The user space can be a low 3G space, while the kernel is staying in high 1G space. Each process has a full address space, isolated from each other. A user application starts with 1 megabyte address space, leaving blank in front to prevent long points from being accessed, and all address spaces are mapped to form their own virtual address space from the physical memory space. As shown in the picture, application parameters and the environment variables are reserved on the 4 KB. That is ahead of the high 1G address. I will now show you the system service on user space. RTOS Smart provides a variety of system services on user space. For example, user space file system, byte and ex5 file system, flash file system, YAFS, JFS2, etc. User space network protocol stack LWIP provides a complete BSD socket programming interface and support TCP, IP, v4, and v6 dual stack. The user space graphic user interface is based on our commercial POSIX UI, provides a modern UI effect, supports JavaScript programming, and includes rich widgets, animation, and available for customizations with all kinds of cool effects. If the underlying hardware has GPU capability, it will be available for adaptive and with GUI display acceleration. Now, let's consider the real-time performance. RTOS Smart continues the excellent real-time performance of RTOS. Take the case of a test on a single-core Cortex-A7 chip. When 14,000 interrupts are triggered, the interrupt latency is less than 1 microsecond. The chart clearly shows that most interrupt response times are within 215 nanoseconds. RTOS Smart at the beginning of design, we considered supporting the complete POSIX API. In user space, it's fully compatible with the PSE 15.3 interface, including process-oriented fork, VFork, PEPL system calls. Also with a socket abstract layer to do the socket abstraction. On top of that, we also provide a Unix socket, a light link, and some other functions. RTOS Smart on user space use the master-libc library carrying complete POSIX threads, making it very convenient for some open source software porting. In addition, RTOS Smart also supports the complete C++11 standard, including the parallel programming such as std thread, mutex, condition, etc., and the auto data type, lambda express, etc. There is a compatible environment in RTOS Smart. In addition to sconce building tools, RTOS Smart supports many ways to build user applications. For example, makefile with automake and auto-configure, cmake, even though the xmake. Therefore, many GNU applications can be easily ported to RTOS Smart. The all-in-one toolbox, the buildbox, only with manual configure and build, and then can run on RTOS Smart with a lot of functions, from the Achieve tools to network tools. Also, many network tools are ported into RTOS Smart. wget, CURL, and the NIT HTTPD, UHTTPD for web server. SSH server, the Dropbear SSHD. On multimedia, the FFmpeg is ported to RTOS Smart to decode code and display it on the screen. Others, such as SDL, SQLite, are all supported. If you want to use the script for programming, Python is available. RTOS Smart continues some performance of RTOS system as it includes the traditional API of RTOS on user space, which means the original RTOS program can be easily used on RTOS Smart. Most than that, user space programs support the traditional build method on RTOS using scans to build programs, and you are allowed to connect with the RTOS online software packaging ecosystem. As you may know, there are over 400 various types of software packages, such as AI-oriented programs, web client and web servers, MQTT, etc. When it comes to RTOS Smart programs development, I would like to introduce the RTOS Smart extension on VS Code. This extension provides create application, build a kernel, and user application functions. And by using some remote extension on VS Code, landing on the Windows host and logging into the Linux server for remote development, it works very well. Similarly, VS Code and the Smart extension make full use of this. In this way, RTOS Smart can support the Windows platform, Linux platform, and the remote logging mode, providing great convenience. When considering more open source porting, we recommend the development mode under Linux. On RTOS Smart, the GDB server is provided to debug the user space programs. It does not require JTAG. We only need to connect PC and device via the serial port or network. Compared with VS Code and the Smart extension, we can easily connect the GDB server on the device side and use VS Code graphic debugging function. I will present two videos to make a further explanation. This is a little video. This video presents the basic functions of the Smart extension. This is a simple Hello program. We just modify the code with some counter output function. And then compare it to download. And switch to the terminal window. Just enter hello.ef. It's run. Okay. Let's see next video. This video presents debugging features. First, on the PC side, runs the VS Code and the Smart extension. On the board side, run the RTOS Smart and the UDB services. After downloading the program to the board on VS Code, you can start debugging. Here, we use the Linux host mode because it developed by remoting connecting to Linux server. Okay, now it's in debug mode. Let's switch to theory terminal. Take a few steps. Okay, we can see hello world display on the terminal. Keep going, the output continues. With Smart extension, it's quite easy to develop by using VS Code. Recently, RTOS Smart supports a variety of chips and development boards, such as the Raspberry Pi 4B, NXP Idol Max 6 UAL, Xenix Zinc MP SOG Ultra Sky, STM32 MP1, etc. but also support RISC-V, such as the Arduino D1 chip and the NERJA board. RTOS Smart is an open-source operating system. On top of that, we have a functional safety certified version. RTOS Smart for Safety has been TÜV certified by SDS February 2022, including IEC 61508, C3, EN 50128, and the ISO 26262 ACOD for automotive. Happy to share that RTOS Smart has been applied in several fields, including digital dashboard, automotive system, tracker, signal system, industry gateway, etc. Okay, that's all for this presentation. If you are interested in the RTOS project and the RTOS Smart, please scan the QR code and let's connect. Thank you.